Recorded is rolling. It is Monday, April 6th. We're going to do lesson 10.5, probability and the addition rule. This has to do with mutual exclusivity. I'll walk you guys through some examples. Tomorrow we'll do 10.6, and that will be the last lesson of module 10, the probability module. There's a assignment on Alex 10.5, 10.6, so that's due at the end of the week. We'll do a Kahoot review on Wednesday. Thursday will be an Alex day. And then Friday, I'll get you the Model 10 quiz. Okay, so you guys know what's going on this week? Okay. And then back last week, you guys were doing board game projects, and most students presented, but there's still a couple of you guys that have to go. So after I have you guys take notes and turn these notes in, I'll just do a few examples with you guys then. And time, have you guys present your games if you hadn't presented yet. Okay, so I got some Venn diagrams that's going to explain a lot what's going on in this lesson. Okay, so are events mutually exclusive or are they not mutually exclusive? And what could that mean? So let's say I got some cards here. So cards is a good example. How about this one, this one, and this one? How about this? Okay. Okay. Now, what if I say I draw two cards? Guys, can let's draw one card. That's what I meant. Okay. Guys, if I draw one card, is it possible that it could be a king? Yeah, right, could be. Right. Is it possible that it could be a jack? Like if I don't know. Yeah, it could be. Right. Could it be both a king and a jack?
No.
No. There's no such thing as a card that's both a king and a jack. So could you put kings and jacks as two circles that don't overlap at all?
Yeah.
You have kings here and jacks here. Right. But could a what if I said instead could it be a king and a diamond? Is that possible?
Yeah.
Yeah, because there's some overlap. Maybe I put kings here and I put diamonds here, and of course there are cards that are neither nor, right? But there is some overlap. Actually, there's one card that overlaps. There's one card that's both king and diamond, right? So that would be not mutually exclusive. Now, how do you handle probabilities? Like, what is the probability of drawing a king or a diamond, or versus a king and a diamond, right? So, if two events are mutually exclusive, that means these Venn diagram circles don't overlap at all. Then the probability of one or the other happening, you can very simply add together the individual probabilities. So in my example, guys, how many kings are there in the deck?
Four.
Yeah, four, right? Right. How many jacks are there in the deck? Four. So if I said the probability of drawing a king or a jack, could you just say 4 out of 52 for the king and 4 out of 52 for the jacks? You add those together? Okay. But what if I change the question to a king or a diamond? Ooh. So could you say 4 out of 52 for kings and 13 out of 52 for diamonds? Okay. And you could just add those together, but the problem is you're double counting one of the cards, right? So you have to subtract out that one card of probability of king and diamond, which is only one card in this case, so that you're not double counting it. Is how that works? Okay. All right, so let's jump into some examples here. Examples. All right. So a pre-recorded video, I did all these main examples to start with. But someone had a start here that I had not done on the main video yet. Right? It's a whole bunch of questions about cards in a deck. So pick one of these up. How about the probability of a queen or a heart? It's pretty similar to what I was just saying. So this is number 11. So write your name on your paper. Guys, everybody name on their paper. So we turn this in. I'll know who to give the points to. All right, let's call this lesson 10.5 notes.
And some of the titles.
All right, so you got your name and lesson 10.5 notes. All right, and we're going to do 3 examples at least. Okay, so number 11. What's the probability of drawing a queen or heart? Oh, queen or heart. Right. Okay, so since I know that there is non-exclusivity between queen and hearts, because you could have a queen that is a heart. I want to think about these overlapping circles. Okay? Okay, and if that's true, I can add the probabilities of queens and then hearts, but I have to subtract out queen and heart because I don't want to double count it. Okay? So this would be probability of queen plus the probability of hearts minus the probability of queen and hearts. Right. That could be probability of queen or hearts. So or could be either or, and you need both conditions to be true, which could happen in this case. Okay. So guys, what fraction do I put right here for queens? What over what? How many queens out of how many cards?
50 here.
Yeah, 4 out of 52. Right, it's 4 queens in a 52 card deck. How many hearts in a 52 card deck?
13.
13. Okay. But how many queens are hearts? 1. So I don't want to double count it, so I have to subtract it off. Because otherwise it's counted here and it's also counted here. Okay. Okay, you guys get that? Okay. So that's what's is that 16, I think, out of 52? Okay. And that could reduce. I think each of these are divisible by 4. So that's 4 out of 13. Or 0.308 or 30.8%. Okay. So I have a shuffled deck and I pulled a random card out of it and said, what's the probability it's a queen or a heart? That's going to happen 30.8% of the time. So if I do 100 drawings, probably about 30, 31 times somewhere there, that'll happen. All right. All right, guys, good. Got an 11. Got that in your notes. Good. All right. Now, this next one I did do on the longer video, but I want to do it in class anyway because I really like the visual. So there's Valley View High School, and there are these 3 different clubs. There's a drama club, and a band club, and an athletics club. Okay? Actually, the first thing I'll do is I'm just going to copy down that diagram. Yes. This is number
67.
16. Yeah, as it would be. Okay, so there's all these students in the school, and there are these 3 clubs. And you can be part of 1 club or 2 clubs or all 3. Okay, so we got some drama going on here. We got band going on in this circle. And we got athletics going on in this circle. Okay. And outside the circles is maybe students that aren't in any club at all. So maybe I'll maybe I'll mark this big box like all students. All students. Okay. And if they're in this margin space inside the box but not inside the circles, maybe they're not taking any clubs at all. Okay, so strictly drama is 38. Strictly band. Okay. Is 51. Strictly athletics is 137. Okay. But are some students that are part of both clubs. Like there are 30 students that are in drama and also band that I hadn't considered yet. There's 4 students in both drama and athletics. There's 8 students in both band and athletics. Okay. And there's 10 students in the whole school that are in all 3 of these clubs. There's 10 of them. Okay. Furthermore, there's 67 students not in any club at all. Right. Okay, so now we've accounted for all the students. Okay. All right, so there's a few questions about this Venn diagram, but here, I just got this one started. So, okay. So let's just do question C. Question C says, if a student is randomly chosen, what is the probability that the student participates in athletics or drama? So what's the probability, so P for probability, of athletics or drama? Right. Which could be athletics, could be drama, could be both. Doesn't have to be both. Okay. If I change this word to or to and, then that would have to be both, wouldn't it? Okay, but or could be either or. Okay. So I think it's going to be probability that you're in athletics plus the probability that you're in drama minus the probability that you're in athletics and drama. Okay. We'll calculate this 2 different ways, and I'll show you guys that it's the same answer regardless of how you calculate it. And this is the setup that follows what we've been doing so far. Okay. There's overlapping circles on the Venn diagram. You want the or condition. You add it to the circles and then subtract out the intersection so you're not double counting it. Okay. So athletics. Well, how many students are in this whole school? Let's add all these up. Okay, so there's.
9.5.
But you got how many? Here, well, I'll let myself too.
Oh, I thought you were talking about that.
Yeah, I'm adding up all the students in the school. I'm getting 345. Okay. Are you guys also getting 345 students in the school? Okay. Okay. And athletics is, well, there's these 137 that are only in athletics, but let's not forget these 8 that are athletics and band, these 4 athletics and drama, and these 10 in all 3 clubs. Oops, plus 8, there we go. Okay. I'm getting 159 that are in athletics somehow, not necessarily exclusively athletics, but they're in athletics. Okay. Plus, right now drama, so we're drawing from the same well of 345 students. Okay. Now drama, there's 38 only in drama, there's 38 drama band, there's 4 drama athletics, there's 10 in, of course, all 3. Okay. So that'd be 82. Okay. Now I have to subtract out the probability that you're in both athletic and drama because I've actually double counted those students. So out of 345, okay. You guys, what number goes right here? 14. Yeah. Okay. Because athletics and drama could be these 4, and don't forget that also those 10. Okay. Okay. So let's say what's 159 plus 82 minus 14. So I'm looking at 227 out of 345. Okay. And what is that as a decimal? Okay, 0.658 or 65.8%. 65.8% of students that condition, that work condition. Okay. All right. Okay. Now, there's another way you could have approached this. It should be the same answer, which is, let's see, athletics or drama. I could just add up all the relevant wedges. Okay. So I could say probability of athletics or drama equals. Okay. Now I know there's 345 students altogether. Okay. And I can just add up the wedges that are relevant to this condition. Okay. So I got these 38 students here. I got these 30 students here. I got these 4. I got these 10. I got these 137. Okay. So aren't those the 5 wedges that can be relevant to this or this? You see that?
Yeah.
Okay. All right, let's see what this adds up to. It's 38, 30, 4, 10, and 137. All right, hold on. Why did that not come out the same? 38, 30, 37. Did I miss something here? 38, 30, 4, 10, 137. Okay. You know, I did this ahead of time. This worked. So, yeah, so somewhere my numbers are messed up. I should have gotten this.
82.
Huh?
How do you get 82?
82 for drama? Let's see. What's 38, 30, 4, 10. That's 82. Okay, what's athletics? 137, 4, 10, 8. It's 159. Oh.
Yeah.
I see what it is. I see. Okay. Guys, my athletics, I missed these 8 students right here. You guys see these 8? I think it's this number right here.
That's 12. Oh, yeah.
That would actually make this throw this off more. 137, 14, 8. No, I did count for them. Let's see. No, I see what it is. I did, okay. It is these 8, but that's my most recent calculation. Okay, so I missed some. 1, 2, 3, 4. That's what it is. Okay, because I need to add 8 up here. Oops, I missed these 8 guys who are in athletics. So that changes this 219 plus 8. There we go. It is 227. 227 out of 345. There we go. Okay. I just missed those 8 students right there. Okay. All right, so there you go. There's 2 different ways of doing it, and we got the same answer. All right, that working out? 2 different ways, same answer. Is that? All right, let's do one more for the notes. One more. I got number 20, pets. Got Ruby's cat had 8 kittens. This is number 20. 8 kittens. The litter included 2 orange female, 3 mixed color female, 1 orange male, 2 mixed color male. Ruby wants to keep 1 kitten. What's the probability she randomly chooses a kitten that is female or orange? So, one trick is to figure out how to draw the Venn diagram. Yeah, what I'm thinking is that here, go ahead and draw what I would draw, and I'll take it as why I'm drawing it this way. Okay. You can see how these circles overlap in some ways and not other ways. Okay. So I think one distinction is going to be either male or female, and there would be no overlap between the male and the female. Another couple of circles could be either orange or mixed color. And again, those circles are not going to overlap. You're not going to have both orange and mixed color. So you have to be one category or the other. It can either be orange or you can be mixed color, but not both. Okay?
Yeah, I do.
Now there will be overlap or potential overlap between the colors and the genders. Right? You could have that. You have overlap there. So let's take the numbers from the story and put them into the diagram. Are you guys okay with why I set the diagram up that way? Okay. Right. So 8 kittens. We need to account for 8 kittens. So we got 2 orange female. You can see where 2 orange female would go? That's right here. Bam. There's 2 kittens on the board. 2 orange female. We got 3 mixed color female. So female, mixed color. There's 3 of those. 1 orange male. So that's right here. 1 orange male. And 2 mixed color males. That's these 2 right here. Mixed color male. Okay. Because what do all those numbers add up to? 8. So now we've accounted for all 8 kittens. Now you could, I guess if you expand the number of kittens you're looking at, you could have like some black cats that would not be orange or mixed. Okay, so now that could go in these bubbles here, something like that. Yeah. And this is all the relevant kittens. And what was the question? What the probability she randomly chooses a kitten that is female or orange? So what's the probability of female or orange? Okay. So I think it's pretty similar to the last question we did. So there's 2 different ways we could do this. We could add the females, add the oranges, and then subtract out the intersection. So let's do that first, and then we'll do it the other way later. Okay. So probability of female could be 5 out of 8 cats. Do you guys see 5 out of the 8 cats are female? Okay. Plus, guess what proportion of the cats are orange?
Well, never had 3.
I think 3 out of 8. You guys see there are 3 orange cats out of the 8 cats. Okay. But we've double counted some of these. Because some are both female and orange. How many are both female and orange? 2. That's of course out of 8. So put this all together. Is that 6 out of 8? No, which is like 75%. Okay. Right, so that's the answer. What's the probability of female or orange? Well, this 3/4 that that applies to. Okay. Now, the other way you could have done this is you could have added up these wedges individually. You could have said probability of female or orange. Okay. And then said, okay, well, I know there's 8 cats, and there's 3 of these wedges that is one condition or the other. There's 1 there, there's 2 there, there's 3 there. And that still gets you 6 out of 8 or 75%. So it's the same answer. All right. All right, so recap here. If actually the examples we focused on today were really these were non-exclusivity. Okay. So one approach is you can add each individual probability, but then subtract the overlap, and that can give you the probability of one condition or the other condition. Okay. Now, don't forget this too: is that if events are mutually exclusive, like could I draw a king or a jack where there's no overlap? You can. It's even more straightforward. You just add the probabilities together. There's just no overlap. Okay. All right. So double check, make sure your name is on your notes. Close down this recording, and I know a couple of you guys still have to present your projects.